This is the notes video for section 2.6, slides 33 and 34. All right, so it says write the equation of line tangent to the curve at the given value of t. All right, so we have x equals 2 plus secant t, y equals 1 plus 2 tangent t, and t equals pi over 3. All right, so I need a point and a slope if I'm going to write the equation of a tangent line. All right, so I'm going to find the point by evaluating x when t is pi over 3. All right, so 2 plus the secant of pi over 3. All right, so remember, secant of pi over 3. Secant is the reciprocal of cosine. Cosine of pi over 3 is 1/2. So secant would be 2. So this is 2 plus 2, or 4. All right, then I also want to evaluate y when t is pi over 3. All right, so 1 plus 2 times the tangent of pi over 3. All right, so tangent of pi over 3 is root 3, so this would be 1 plus 2 root 3, and I cannot simplify that any further. So my point is going to be 4, 1 plus 2 root 3. All right, now I need a slope. So slope of the tangent is going to be found by evaluating dy dx at t equals pi over 3. So first of all, I need to find dx dt. Sorry, dx dt. So derivative of 2 is 0. Derivative of secant of t. All right. Derivative of secant t is secant t tangent t. All right, and then dy dt. All right, derivative of 1 is 0 plus 2 times the derivative of tangent t. Derivative of tangent is secant squared t. All right, so now I find dy dx by taking dy dt divided by dx dt. Of course, then the dt's reduce, and I'm left with dy dx. All right, so dy dt, 2 secant squared t divided by secant t tangent t. All right, and so now I look and I can reduce here, right? Secant squared over secant, so that would reduce. So I'd be left with 2 secant t over tangent t. All right, now you could look at these a little further. Secant is 1 over cosine, right? So 1 over cosine t, and tangent is sine t over cosine t. Right? And so you realize that if I'm dividing by sine over cosine, that is like saying 2 times 1 over cosine t times the reciprocal of sine over cosine. So that would be cosine t over sine t. And so now we actually reduce further. The cosines reduce. So I'm left with 2 times 1 over sine, or 2 cosecant t. All right, so now in order to get the slope of the tangent line, I'm going to evaluate dy dx at t equals pi over 3. And so 2 times cosecant of pi over 3. All right, so remember, cosecant is the reciprocal of sine. And so I have 2 times reciprocal of sine. Sine of pi over 3 would be root 3 over 2. So this would be 2 over root 3. So 4 over root 3 would be our slope of the tangent. Yes, you could rationalize, and that would be by multiplying by root 3 over root 3. And so I would get 4 root 3 over 3. All right, so that's the slope of the tangent line. All right, and so now I take my point and my slope, and I write the equation of the tangent line. All right, so y minus, now remember this is 1 plus 2 root 3, so that needs to be in parentheses so that you would remember to distribute the minus, equals slope of 4 root 3 over 3 times x minus 4. All right, and so that is slide number 33. All right, slide number 34. Given that x equals 4t squared plus 2 and y equals 8t cubed minus 2, find dy dx, find dt of dy dx, and find ddx of dy dx. All right, so first of all, I'll start off with dy dx. All right, so we know that dy dx is going to be dy dt divided by dx dt. So let's start there. All right, so dx dt is going to be derivative of 4t squared, so that's 8t, that's easy. Dy dt is going to be the derivative of 8t cubed minus t, so 24t squared. All right, so now I'm going to take 24t squared divided by 8t. All right, now do yourself a favor, simplify this. T squared over t, that just becomes t, right? And 24 over 8 becomes 3. So 3t is dy dx. All right, now it says d dt of dy dx. All right, so remember, we're taking the derivative with respect to t. So d dt of just 3t, right? So what would that be? That would just be 3, right? We're taking the derivative with respect to t, okay? All right, so now, okay, we want to think, well, what is d dx of dy dx? How does that differ? Well, now I'm taking the derivative with respect to x of 3t, right? And so I have a t inside, but I'm taking the derivative with respect to x. And so you have to realize that t is actually a function of x. And so when I take the derivative of 3t with respect to x, I get 3, but then you have to multiply by the derivative of t with respect to x. But what is dt dx? Well, dx dt was 8t, so what does that mean? If you take the reciprocal dt dx, that would be 1 over 8t. And so I get 3 times 1 over 8t, right? Or you get 3/8 t to the negative first. And that is slide number 34.